Math 50, section 6.4, talks about square roots in the Pythagorean theorem. Okay, what is a square root? It's a square, well, a square is a number times itself. So if I asked you, if I told you to square the number 5, it's 25 because 5 times 5 is 25. Also, I could say negative 5, the quantity squared, is also 25 because negative 5 times negative 5 is 25. So the reverse of squaring a number is finding the square root of a number. So in other words, if I gave you 25 and I asked you what's the square root of 25, I'm asking you what two numbers multiply to give you 25. And in this case, it could be 5 or negative 5. Okay, that's square root. So basically, we use this square root symbol if you're trying to find out what two numbers multiply to give you a certain number. So if I gave you this is the radical sign. The number underneath is called the radicand. Now, when you get to higher levels of math, it's understood that when you don't see a little number on this ledge here, it's understood to be square root. So in other words, this is asking you, by this symbol right here, it's asking you what two numbers multiply to give you 25. And it's 5 times 5. There's two numbers that give you 25, but also negative 5 times negative 5 is also 25. So what is the square root of 25? Most people will say 5 or negative 5. We're just going to, for this class, give the what we call the principal square root, which is the positive one. We're just going to say the positive one, okay? So here's some examples. So for example number 1, and you're really, when people ask you what's the square root of 49, everyone usually just says 7. And that's exactly what it is, because what two numbers multiply to give you 49? And it's 7. What two numbers multiply to give you 36? 6. What two numbers multiply to give you 1? 1. What two numbers multiply to give you 81? 9. Now, if you have a fraction, you take the square root of the numerator. What two numbers give you 1? 1. What two numbers multiply to give you 36? It'd be 6. And then the same with this square root of 4 over 25. Square root of 4 is 2. Square root of 25 is 5. Okay, so now these are called, these are perfect squares because their square root is a whole number. It's not going to be like a decimal or a fraction. So if I asked you what's the square root of 5, you are going to get a decimal. You'd need a calculator and you hit square root 5. And in that case, you're going to get a decimal. It's not going to be a perfect whole number. Like, for instance, if I said square root of 9, that's 3. Square root of 5, it's going to be a number that's going to be a decimal. So what do you do when you have problems that are not perfect squares, like the square root of 43? Well, you're going to have to find a calculator that, in these cases, has a square root button. Now, you will be able to use a calculator on this portion. The square root of 43, you're going to hit the square root button, and then hit 43, hit enter, and you're going to get 6.557. Square root of 80 is 8.994. You're just going to use a calculator and type it in. Now, different calculators work differently. Sometimes you have to hit the square root button first. Sometimes you have to hit the number and then the square root. So practice. So these would be two good examples to practice on your calculator, and make sure you get 6.557 and 8.944. If you don't, shoot me an email and I'll see if I can work with you on that. Okay. So another example would be, can you estimate without using a calculator some of these problems? So for example, if you look at this right here, here is a list of numbers that are graphed on a number line. So 5 is the square root of 25. Square root of 36 is 6. Square root of 49. These are the numbers that we know. We know 5, 6, 7, 8, 9. You can keep going. So for 10, you'd have square root of 100 and so forth. Well, this question's asking you, without using a calculator, determine which two whole numbers square root of 78 is. Well, square root of 78 is between 8 and 9. Okay? 78 is between 64 and 81. So it's somewhere in between 8 and 9. Okay? If you wanted to know the exact number, you just type that in your calculator, square root 78. The last objective is using the Pythagorean theorem to solve, and you're going to use the square root information in order to solve problems dealing with right triangles. So we're not going to get too much into detail, but when you have a right triangle, that's a triangle that has a 90-degree angle. Okay, so that is, draw you a picture. Okay, you're going to have a right angle, which one of the angles, the sum of the angles of a triangle add up to be 180. So when you have one angle that's 90 degrees, this is called a right triangle. No, the side opposite that right angle is always the longest side, and it's always the hypotenuse. The other two we call legs. And the Pythagorean theorem says, if you square each of these legs, so if I call this A, B, and C, the hypotenuse we'll call C. If you square the legs, so A squared, square the leg, the other leg B squared, add it together, these two numbers is equal to the hypotenuse squared. Okay, so this is what the Pythagorean theorem says. So, and I have it right here for you. So let's do some examples and be on our way. So example 9, very simply, they give you a right triangle, and it has to be a right triangle. Here's your picture, and it's asking you to find the hypotenuse. Find the length of the hypotenuse. Remember, that's the longest side. So what we do, it's the legs squared. So if you want to say A squared plus B squared equals C squared. So square each of these legs. So 6 squared plus 8 squared will give you the hypotenuse. We don't know what it is. So 6 squared is 36. 8 squared is 64. Add these up, you get 100. And now, if we are looking for what two numbers multiply to give you 100, and that would be 10. So you're going to take the square root of both sides, and the square root of 100 is 10. So 10 is the hypotenuse. Okay. Now, sometimes it doesn't come out that it's not, the numbers aren't that easy, but here's another one. We have a triangle, right triangle. The legs are 17 and 10. So we want to know, again, know the hypotenuse. So 17 squared is 289. 10 squared is 100. If you add these together, you get 389. And then you have to take the square root of 389, which ends up, it's approximately 20. It's not exactly 20, because 20 times 20 is 400. So this is it's going to be a decimal, and you're going to have to round to whatever unit they tell you to. Okay. 11, here's another example. Now this one, it's you have to be careful, because here's your hypotenuse right here, because it's always the side opposite the right angle. This one's asking you for the length of one of the legs. Okay. So we have this triangle, and you can change the direction of that. So the hypotenuse is 7. One of the legs is 5. We don't know what this one is. So 5 squared plus B squared equals 7 squared. Well, 5 squared is 25. 7 squared is 49. So you're going to subtract 25. So b squared equals 24. And now take the square root of 24. So that one, since I don't know what the square root of 24 is, I'm going to use my calculator, and that ends up being about 4.9. And the last one, we've got the dimensions of a park. It says the inner city park is in the shape of a square that measures 300 feet, okay? So we're going to, a sidewalk is to be constructed along the diagonal of the park. Find the length of the sidewalk. So we want to know that hypotenuse. So we have, this looks like it's 300 on each side. So we have this square. It's a square. Sorry, didn't drop that great, but 300. Each of these sides are 300. So that's why I know it's a square. Okay, so we're going to build this. We have this diagonal. So we have a right triangle. We want to know this distance right here. Okay, so these would be the legs. So 300 squared plus 300 squared equals the hypotenuse squared. So 300 squared is 90,000 plus 90,000 equals c squared. 90,000 and 90,000 is 180,000. And then take the square root of both, and then it ends up being about 424 using a calculator. Okay, so the length of the sidewalk rounded to the nearest whole foot, this would be about 424 feet. And that concludes section 6.4.